This is using standard deviation to describe students' performance in a math class. This is the pure stat version, meaning it's just stat. There's another version where I use Python, the pandas library to solve this, and I also, basically all the graphs that you see here, I made using Python, well, the pandas library in Python, and you can see all of that in a video, well, in the video that I made prior to this, and that's going to be linked below. Here is a sample of the student math scores, okay? So this is a data set. It's made up of actually, the data set, the original one, was made up of 1,000 students, but we took a sample, right? And, well, I took a sample. I don't know who's we. I took a sample of 10 students from that data set, and these are what they are. And the students are actually labeled by numbers and not names. So we're going to refer to them as students 373, student 229, and so on. The next thing I did is plot a distribution of student math scores. So this is what it looks like. So you have the math score, and then you have the frequency or the count, how many times they come up. So this is a histogram. So the goal right now is to answer the question, how did the students perform in their math class relative to each other? Okay, so in order to answer this question, we have to have something that is fixed, right? Something that we can use as our basis to compare their grades, right? And so what can that be? So if I'm thinking, the first thing that pops up into my head is the average math score. Okay, so if we add up all the numbers as you do, and then you divide them by the number of rows that there are, the number of sets, variables that there are, which is 10, you're going to get 77.5 points. Okay, so that's going to be your average math score, 77.5 points. Now, graphically, it looks like this. So I showed you the distribution before. Now this is the distribution with the average plotted on it. So you can see where the average is. Okay. The next thing you want to do is to find the standard deviation. So now what does this mean in context? This means basically how many points do each student's math score deviate from the average math score of 77.5 points. And this is the formula for standard deviation, right? So we have the square root of the sum of every x value. So for, in this case, it's going to be our math value minus the average, which in this case is going to be minus the math score average, square all of that, and then you add all the numbers, and then you divide, right, by n minus 1. So in this case, it's going to be 10 minus 1. And you might ask yourself, okay, why are we subtracting 1? Well, because this is a sample and not our actual population, we want to make sure that any error that we have, that we can kind of give it, we can kind of calculate it for, we can take into account, right? So that's why we're subtracting 1, because that's our margin of error. It's also known as our determination coefficient. Wow, I cannot believe I just said determination coefficient. I meant degree of freedom, okay? It is also known as the degree of freedom, and in a population standard deviation, you don't subtract by 1 because there is no error to account for. If you're finding the standard deviation of a population, then you are finding, the real thing, the real deal. But if you have a sample and you're finding the standard deviation, you want to account for any error that you might have, and there always is going to be error, so that's why we subtract with 1. So that's that, okay? Calculating standard deviation. So we have our first column, which is the math scores, right? So we have our 82, 88, 74, etc. Now, if we go back to our standard deviation equation, we can see here that the first thing, well, not the first thing, but the most inner thing that we have is actually our x initial, so our x value, minus our x bar, which is our average or our mean, or 77.5, right? So what the second column is actually our math score, right, which is our x, if you want to think about it that way. So it's our x, or our math score, minus our x bar, or our average math score. So it's going to be 82 minus 77.5, that's 4.5. 88 minus 77.5, that's 10.5. 74 minus 77.5, that's negative 3.5, and so on. Now notice that there are some negative numbers, because what this actually means is actually the deviation from the mean, right? So this is how much it deviates from the mean. So 4.5, 10.5, negative 3.5. And we actually don't want to account for negatives when we are adding these deviations to find the standard one, right? So in order to fix that, we are going to square those values. So this third column here is basically these numbers squared. Now we don't see the negatives. And when we add up all these numbers, we get our summation, right? Because if we go back to our equation, this is what we're supposed to do. We're supposed to square the numbers, and then once we have them squared, we actually have to add them all up. That's what the E stands for. So when we add up all these numbers in the third column, we get 1,138.5. So we're not quite done yet. Now that's our E, right? So we plug that into what we have left. So we have 1,138.5. Divide that by n minus 1. So in this case, our number of students is 10, so 10 minus 1. Again, our 1 is our degree of freedom, margin of error. Okay, so that's 9. So 1,138.5 divided by 9, square root that, our standard deviation is 11.2472 rounded. Okay, so that's what our standard deviation is. Now, what does this mean in context? Each student's math score deviates around 11.2472 points from the average math score of 77.5 points. That is what the standard deviation means in the context. Now, let me show it to you graphically. So here you have a table right at the top. We have our average, and then we have one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean, and then we have the opposite. And so I'm going to show you what this looks like visually, if you are a visual learner like me. So again, this is what we had before. We have our average plotted already in our distribution graph. Remember that our standard deviation is 11.2472. So if we're starting with our average of 77.5 and we are going one standard deviation above the mean, that means we are adding 11.2472, which is we're adding one standard deviation. So that is going to give us 88.1230, right? 1231, excuse me, rounded to the four numbers. So when we add one standard deviation to the graph, that's what it's going to look like with that green dashed line. Now, when we do the opposite and we go one standard deviation below the mean, when we subtract one standard deviation below the mean, which is 11.2472, we get 66.8769 rounded. And what that looks like graphically is this, right? When we subtract one standard deviation from the mean. Next, when we go two standard deviations above the mean, that means we have added two standard deviations. That means we have added 11.2472 two times to the average of 77.5. So that is going to look like this with this yellow line. Now, when we do the opposite, we go two standard deviations below the mean. That means that we're going to subtract, once again, 11.2472, and that's what two standard deviations below the mean looks like. And then finally, we have the third standard deviation above the mean. That means we've added three standard deviations to the average. So that means 3 times 11.2472, that's 109.3693. And so that's what it looks like graphically. And then when we do three standard deviations below the mean, that's three standard deviations subtracted from the mean, right? So that's 45.6307 rounded, and that's what it looks like graphically, okay? So now using this plot, we are going to compare the students' math scores relative to one another, okay? So our first student, student 373, this student got an 82 on their math class. We're going to say math class, that this is, their like final score, we're going to say. And they got an 82 on the math class. So what we're going to do is we're going to locate where 82 is on the graph. Now 82 is actually around here, right? So that means that it's between the black line and the green dashed line. So now what does this mean? It means that it's between the average and one standard deviation above the mean, meaning that it's within one standard deviation above the mean. Now, this is how you determine whether they are within average, above average, or below average. If they are within the two green dashed lines, they are within average. In other words, if they are one standard deviation below or above the mean, they are within average. If they are between the two yellow lines, they are above average. Not specifically between, like within, they have to actually be greater than one standard deviation above the mean, but they have to be lower than, they don't have to be lower, but if they are greater than one standard deviation above the mean, but they are lower than two standard deviations above the mean, then they are above average. But they can be right here and still be above average. That would be like super above average because they're within 3 standard deviations above the mean. Okay. But let's say they are below average, right? That means that they're going to be right about here. So this would be like below average if they're between this 1 standard deviation above below the mean and then 2 standard deviations below the mean. That means that they are below average right here. Okay, so um, student 373 with a score of 82 is actually within average because they are within 1 standard deviation above the mean. Student 229 got a score of 88. Now, if you take a look at 1 standard deviation above the mean, it's actually 88.12, so it's right before 88. I mean right after 88, excuse me. So 88 is right before that 1 standard deviation line. That makes it into the 2nd standard deviation. So 88, student 229, excuse me, is actually within average, very close to being above average, but didn't quite make it. Literally by like what, 0.12 points. So 229 is within average because it is because student 229 is actually 1 standard deviation within from the average, right? Student 722 got a 74. Now 74 is right about here, so it's actually student 74 is actually 1 standard deviation below the mean, right? So they're within 1 standard deviation below the mean, meaning that they're actually still within average, right? Because they are still within that 1 plus or minus standard deviation from the mean, okay? Between the two green dashed lines, if you want to think about it that way graphically. Student 909 got a 70. So a 70 is right? So a 70 is right here, right? So that's again 1 standard deviation below the mean. So we can say student 909 is 1 standard deviation below the mean or below the average math score. So they are within average still. Student 194 got a 69. So a 69, if we take a look at 1 standard deviation below the mean, it's actually a, not sure I can see that well. 66.87. Okay, I had to zoom in a little bit there. So this student is a 66, no, I'm sorry. 1 standard deviation below the mean is a 66.87. So 69 is still within average because it is still within 1 standard deviation below the mean. So it's between this black line and this green dash line right here. It's right here. Okay, so student 194 within average. Student 370 got an 84. 84 is actually right about here. They are within average also because student, what was it? 370 is within 1 standard deviation above the mean. Student 689 got a 93. Now a 93 is actually right about here. So this student actually surpassed 1 standard deviation above the mean. This student is actually within 2 standard deviations above the mean. So this student is above average. Okay. Student 519 got a 67. So a 67 should be actually right after here. So a 67 is actually within 1 standard deviation below the mean. So student 519 is actually within average. 708, student 708 got an 89. So this student is right about here. I'm pretty sure 1 standard deviation above the mean was 88.12, so that means 89 is after that, meaning it's within 2 standard deviations above the mean. So student 708 is within 2 standard deviations above the mean, meaning the student is above average. Okay, student 64, we have a math a math score of 59. Now, 59 is actually right at the end, right over here. it's actually two standard deviations below the mean, meaning that the student is below average, right? So student 64 is below average because there are two standard deviations below the mean, okay? So above means you're right. So to the right means you're above, right? When in terms of like the yellow line, so that's two standard deviations above the mean means you're above average. Two standard deviations below the means you're below average, right? And then within average would be between the two dashed green lines. And if you are actually within three standard deviations, so if you're in this column or in the, well, what happened? If you're in this space right here, that means you're super below average. And if you're in this space right here, that means you're super above average. So this is how you can interpret the data. And then let's say you were I don't know, a high school teacher or a college professor. Well, you can use this data to recommend the students who were above average to an honor class next year, right? Because you need to recommend only those who excel in your class, let's say, and those also you only have two students who excelled in your class who were above average, so you recommend those to an honors class next year. Let's say you're a high school teacher and you see that one of your students was below average, then you might recommend them for tutoring, or you might recommend them for the extra help program that your school offers, or the Title I program. Maybe you want to recommend them to that. And then you have those students who are within average, and you can represent that to your supervisor and be like, hey, look, this is my data. Look at how many students are within average versus those who are below average. And I still have like two above average. So I think I do pretty good with my class. And maybe that's going to help keep you. Let's say if like they need to cut off people, and you have all of these people who are within average and you have above average and you only have one below average, and then some other teacher has like 10 below average and like one like three within average and no above average, then you were going to end up staying while the other teacher is going to end up being um what do you call it, asked to leave or leaved off. I don't know, like when they have to like cut because they don't have enough funding. Yeah, so not I know there's probably legal issues with that. Like I don't think it's that easy to just fire you, but in terms of just like analysis purposes to just give you an idea of what you can do with this data, that's what that is. Anyway, that's pretty much it for this. If you want to watch the Pandas version where I use Python to solve STD, that sounds weird. To solve the standard deviation, I just like write it as STD, but I should say standard deviation. So I use Pandas to solve, not Pandas, I use Python to solve for standard deviation. I also code, the graphs. I don't code the graphs in the video, but I have the code there if you guys want to see how I made all the graphs and all the distributions. And yeah, so you can have some fun with that. The link is in the description box below. Thank you for watching and have a great day.